Hello students, now I am going to talk about the part B experiment, experiment number 2. Again it's a serial data communication, but here we are going to write a program in C program, which is called embedded C program. Here we need a cross compiler rather than a normal compiler because it's a blend of both embedded approach, that is microcontroller, as well as a normal C platform. You should be aware of the calculation part. Earlier, for normal timer operation or counter operation, your extol oscillator was divided by 12 to generate a machine cycle frequency. But now, for the serial communication, they have some specific standard. So again, it is divided by 32. Notice that dividing 1 by 2 of the crystal frequency by 32 is the default value upon activation of the 8051 reset pin. I have to achieve the speed compatibility. So for that sake, we have to use an internal timer again, and we have to move a particular value so that I can get the specified baud rate. So in this way, this calculation is used here, and this value we are going to move to the respective timer. In that sense, it is going to create enough delay to transmit each character by character, and it maintains the speed. Let's look into the programming aspect, where the first hash include register 51h dot h. In a normal C program, we were using standard library stdio.h, which includes your printf scanf statement, but now register 51 is used for the 8051 family. In this, all the SFRs are by default it's a built-in functions, special function registers like accumulator, SCON, timer, many PSW. So ports, all the ports, you can directly make use of that. So by mentioning tmod, it is acceptable. Here we have to inform the cross compiler saying that I have one subprogram, and you have to consider that subprogram. The subprogram here, as I have mentioned, the same title need to be put here. Whatever the function we are using there, that must be reflected here. So that's why I am writing the same here, well informing before that I am going to use one subprogram in here in this complete program. Coming to the main program, here the declaration or the variable declaration is SMVITM. That means we are going to transfer SMVITM from your microcontroller to the PC. Okay, and we may require some character type variable declaration ID and key to access this each character one by one. Your 8051 is working with this frequency. Again, we should reduce this baud rate to achieve compatibility with your PC. So for that we have to create some sort of a delay. So for that we require a timer. Internal timer must be used. Timer mainly built to create a delay, to generate a delay. Now by moving 20 to the tmod 0x20, here x indicates which is a hexadecimal value we are moving to the tmod register. This will set timer 1 mode to 8-bit auto reload. Then th1 is moved with the fd. FD is because must be loaded to set the 9600 baud rate. Where you can observe this is the formula where -3, either you can move -3 or FD is loaded into the th1. Why we have to use this? Because when I divide this frequency by 3, you are going to get 9600. Next, SCON. SCON is serial control. Since we are using a serial communication, and again I have to set the 8-bit special function register. So by moving this, we had already discussed in the previous video, where mode 1 serial communication, which is 8-bit, 1 start bit and 1 stop bit, is framed. Total 10 bits data communication happens, and this must be 1 in the serial communication. This is a receiver enabled. In order to initiate the timer operation, we have to make TR1 is equal to 1. So initiating the timer 1 operation. Next one is the accessing the character, each character or element from an array one by one, starting from S. How we are going to access? Using this for loop. Look at this, the for loop expression here, where I is equal to 0 and I is less than 6. Here this number we are limiting just because we have here 6 characters. Then key is equal to array of I. When I is 0, array of I in 0 in the sense it is going to access yes. Yes will be accessed here. The key will be having yes, and I am going to transmit from 8051 to the another DTE, say your desktop PC. So how we can do that? By using this function. So this key, which is nothing but your S character, will be sent using this function. So it's a calling function, and the call function is here. The character X. Now this will be the parameter is passed here. As we know, prior to transmit any data or any character to another device DTE, it must be saved in a loaded in a SBUF. SBUF is a serial buffer register, which is again 8-bit register. And once we load it, now we are set to transmit. So now we have to monitor the transmission process. How it can be done? So by using this particular while loop. Actually, the while loop is terminated in the same statement. How this will execute? This is written here. This will be true till it finds the last bit in a frame, which is a stop bit. So that means till it finds the last bit, which is a stop bit, this will be a true. TI will be monitored. TI is transmission interrupt flag, and this will be monitoring the transmission whether it happened properly or not. If not happened, so this will be in a same loop. It will not come out. So when it finds a stop bit, that indicates the transmission of a character is successfully done. So immediately the TI will become 1. So this then immediately it becomes a false statement. So it comes out, and immediately TI will be again made as a 0. They are reinitiating it as a 0 just because still we have to send so many characters like M, B, I, T, M. So in this way, every time we are going to send each character one by one by utilizing this functionality called function. So after that, it again goes back because the loop is not completed. Again, it will be incremented. It's a post increment operator we are using. So after S, now M is accessed. Again, it will be calling the subprogram and transmitting the data in a one by one character. One by one, it will transmit properly, and henceforth the transmission will be done in this way. Thank you.